A very warm welcome, everyone. Thanks for joining us today. I'm Shobna, TME for Aruba Campus Switching. So today I'm going to present one of the AOS-CX 10.13 release anchor feature, reflexive policy, covering the support for reflexive port access policy and reflexive group-based policy. So it will be a quite interesting session with lot of technical details. So kindly stay focused on it. So you could see the list of acronyms used in this session. So you can refer them later after the session is completed. So we'll start with the overview. So before I start the overview about this reflexive policies, let's learn the basics of it in this overview section. So foremost is secure policy. So what is a secure policy? So when policy is applied to secure clients, that is clients who have successfully completed the authentication process, we call it as a secure policy. So there are two types of secure policy. The first one is port access policy. So it is like a set of rules to restrict, means permit or deny the traffic or alter the passage of ingress traffic. Like you could do a rate limiting or redirect in case of captive portal or modifying the QoS from the secure clients. And this is achievable using local user rule, downloadable user rule, and vendor specific attributes like filter ID and NAS filter rule and Aruba NAS filter rule. So example, like you wanted to completely drop the incoming UDP traffic from the end client, it can be achievable using this port access policy. So next comes the group-based policy. So group-based policy in a VNBT, that is a virtual network-based tunneling deployment. So basically it is a role-based policy. So it is helping in segmenting the traffic. Either it can be a micro or macro segment the user traffic in a network by grouping the users into roles based on the user authentication at the source or in the ingress VTEP tunnels. So these are achievable using LUR and unofficially using DUR. That means DUR support is technically possible, but no official validation yet. So let's consider this VNBT deployment for this GBP. So we wanted to restrict any traffic from the employee should not reach the surveillance camera. So it can be easily achieved using group-based policy rules. So by checking the group-based policy IDs in the ingress VTEPs. So this group-based policy is a huge topic. There are a lot of internal and external TOI contents available to learn more about this GBP. So I would recommend to revisit them for further details about this group-based policy feature. So let's start with the reflexive policy overview. So before we understand any feature, so it becomes responsible for us to learn about the pre-existing behavior corresponding to that feature. So let's see what is the pre-existing behavior before this feature introduction. So prior to 10.13, the secure policies which we discussed, either it can be ingress port access policy or egress GBP policy, will restrict the traffic flow in one of the directions. But the reverse flow that belongs to the same traffic application will be requiring a separate policy entry in the opposite direction. So it may increase the configuration complexity as we have to keep watch of all the rules and it can be prone to errors as well. Apart from that, it is not scalable as requires additional configurations in both the ends. We have to do the configuration and also we have to accommodate the infra changes. So reflexive policies came to the rescue in 10.13. So what we could achieve with the reflexive policy? So with reflexive policies, switch will maintain a flow table for permitting the traffic flow based on the policy and automatically allows the return traffic for the permitted flows. So basically, switch enables to check the packet for the authenticated client. Only if the flow is learned and initiated by the client, it will be allowed. And reflexive policy is supported in both the secure policies like PAP and GBP. And it is part of CX Advanced Feature Pack. So currently there is support for TCP and UDP based applications, both IPv4 and IPv6 traffic. And supported platforms are 6400 V2 and 6300. And it is achievable using LUR. And in case of reflexive PAP, it can be achievable using DUR. So let's see the overview about this reflexive policy. So I will call it as a characteristics of a reflexive policy. So consider a client-server interaction. So this is necessarily can be a client-server interaction, but can also be called as the other client in the reflexive policy concept. For better understanding, we are using this client-server interaction overall in this feature TOS session. So without the client initiating any traffic with reflexive policy, the server initiated request will not be accepted. Only when the client initiated the traffic, the server response will be honored and it will be allowed. This is the main characteristics of a reflexive policy. So how it is able to achieve it? So there is a new action introduced to secure the policy, that is a reflect action. So this reflect action enables the switch to allow the return packet destined to the client only if the flow was initiated by the client and it got learned and programmed in the switch flow table. And this reflexive action associated to the matching class entry is always a permit. We can control only the permit workflow. So how does it able to achieve it? So it uses the source destination IP, source destination port are tracked in the ASIC flow table to allow the return flow in the TCAM. So as I said earlier, the supported protocols are TCP, UDP, unicast traffic with IPv4 and IPv6. And it is available for both the secure policies, port access policy and group-based policy. The other point to be noted here is the feature design. Like secure policy can contain multiple classes. So even if one of them is a reflexive, the permit rules for the reverse flow of those non-reflexive classes will also be created. So you will be seeing these characteristics in detail in the details section. As I said earlier, this feature is part of advanced feature pack. So there may arise a question, why particularly this feature? So the reason being is it's one of the advanced security feature with threat intelligence. So I can guarantee at the end of the session, you will completely agree to this point. So we'll see in the coming slides. So use cases. This is one of the much interested topic in this session. The first use case is operational simplification of secure policy deployment. So let's see the difference in behavior between the releases. So for this use case, how it is lacking till now and how reflexive policy will help to achieve it. So consider the same client and server interaction. So first, when a client initiated traffic, this can be a secure access port. So only when the client onboarded successfully, the client can able to send any traffic. So how do we protect the client port? So we will try to create a policy in the user role of the client. That is a PAP policy. So that policy will control what type of traffic and what type of destination this traffic can be allowed. So this is the policy applied to the client via the rule. So next is server response to this client requested traffic. So how do we control it? So we will try to configure a policy. It can be a policy to the interfaces like physical interfaces, lag or VLAN interfaces, and we will make sure only those traffic can come from the server from to the client network. So we will create a separate policy for this purpose. So we have to have policy in the client connected interfaces. We need to have a policy in the server connected interfaces as well. So what is this helps us to achieve? We could secure both the client connected port and server connected port, but there are drawbacks associated with this method. The first one is it increases the configuration complexity and prone to errors. Consider I have allowed certain applications here or destinations. Now I wanted to add new server and on their destination. So we have to add it in both the places, both in the client connected interfaces and server connected interfaces. And if we miss in one of the side, it will be like a security hole. So we need to be cautious about this configurations in this deployment. Next is it is not scalable. The major problem here is it is only to the particular interface or VLAN or that. If there is a new member in a switch or new LC has been added and the server connects in those LCs or members, we have to do the configuration again in those LCs and then the members. Hence, it is not scalable for an enterprise deployment. So far we have seen both the advantage and disadvantage of this deployment. So let's see how reflexive policy will help in this workflow. The main advantage of reflexive policy is when server initiated any request to the client, it will be dropped because there is no client initiation. So only when the client initiated the request, it will be allowed. So how do we try to safeguard this? So similarly, it is a client port connected with the .NX or MacAuth enabled port. So we will try to apply a policy to the end client in the role. So this policy can restrict the application and then the destination where this traffic can reach. Along with that, we have the reflect action enabled. So with that reflect action, we could safeguard like only when the client initiated the request, then the server response will be accepted by the switch. So with this deployment, we could achieve ease of management. We do not need any server-side policy configurations, and we can also capable of handling server-connected interface movements because we are programming this reflexive policy logic in all the LCs and members. So when the server connects in a different LC or member, we can able to handle the server response to the client. And next is it will be scalable. Like this configurations with like if you try to add only the reflect keywords and even if you wanted to add additional destination and then application, it can be easily added in the policy applied to the end client alone. So that's how the reflexive policy, it's a saver. It helps in operational simplification of the secure policy deployment. So the next major use case is aligned to the objective of feature pack, that is advanced security and threat intelligence. So let's hear about the reflexive policy helps in protecting us against this cybersecurity attacks, be it DOS, that is denial of service, distributed denial of service, and WAN propagation. So first we'll hear about these attacks and then we'll go with the protection methodology. So first is denial of service and its counterpart, distributed denial of service. So in both these attacks, one or more malicious servers, or it can be also a clients, target the bandwidth of the end clients by making them unusable by flooding unwanted services to the end clients. So they will be disrupting the services of the end clients, the bandwidth between the end client and then the access which will be compromised because of this malicious attacks. So consider even the end client, the other side can able to send this malicious services to the end client in the other side. So this attacks can be, as I said, it can be from the server like a vertical propagation, or it could be from the end clients in the other side as a horizontal propagation. So next is worm propagation attack. So what is a worm? So worm is like a malicious program or application that can spread into the inclines by itself, like it relies on the vulnerabilities in the network. If there is the network has some vulnerabilities, this worm applications can replicate and attack the systems in the network. So it usually attacks the system which don't control the type of application or its originating sources. So due to the worm's replicating nature, it has the capability to spread itself over the network and it can damage the bandwidth and security of the end devices. So it may impact the normal services of the end clients. That is a major drawback with the worm propagation. So all these attacks, as I said, can happen vertically and horizontally as well. Let's see how reflexive policy will be able to protect us from these attacks. So with reflexive policy, we can have greater control on deciding both the application type, like if this incline wanted to use only SSH, Telnet, SNMP application from the server form or from the inclines in the other side, and also the destination of the application. So majorly when client initiated a particular application service from the peer, the corresponding application service is only allowed. So without client initiating the service, the server initiated responses will not be honored. It will be completely ignored. Apart from that, if a client has disconnected the session, the peer can no longer flood that service to the client. So with that approach, we can protect our end clients from all the cybersecurity attacks, be it denial of service, distributed denial of service, or the warm propagation. Only the requested applications traffic can reach the server, and only if it is initiated by the end client. So now we have seen like reflexive policy is really important feature to be configured to secure our network. So next comes the micro and macro segmentation use cases with group-based policy, that is role-based access control. So here is a VNBT deployment. We have access VTubs connected with inclines like admin and cameras present. So this is a virtual network-based tunneling deployment. And we have a condition here. Like admin role is permitted to access the camera role only for the TCP application. But all the traffic from the camera role to the admin role should be blocked. So we do not want the traffic from the camera to reach the admin unnecessarily. So what happens in this method is the traditional policy, group-based policy will block the reverse traffic. Like if you wanted the admin has initiated a TCP application and if camera responds to the TCP application, traditional group-based policy will be blocking it as it has implicit DNI as well. So because of this, the valid traffic flow from admin role to camera will be disrupted. So how we can achieve to address this currently? So we would be creating a reverse policy that allows the specific TCP from the camera to admin. But this will not be scalable. Like application wise, you have to keep on adding the permit entries. And it can also result in overly permissive. Like we started saying, like suddenly all the traffic from the camera will be able to reach the admin. So it will be against our Aruba's goal of zero trust security requirements in an enterprise network. So how this problem can be rectified using the reflexive policy? So reflexive policy works as a charm in this scenario. So it will allow the specific return traffic, like if you wanted to do a particular application from admin to camera, so that specific return traffic will be permitted by the reflexive policy using a reflect action. So consider this example configuration where I have created a GPP IP with a rule stating the TCP traffic from camera to admin has to be allowed. So here I'll be adding action reflect. With that means only if there is the admin initiated traffic, then the corresponding traffic from the camera will be allowed. So this is how we will be able to protect the communication between the admin and camera. So only when admin initiated traffic, the corresponding return application traffic is allowed from the camera. So now we have come to the configuration section. So here is the configuration task list for the reflexive path feature first. So this is a feature not enabled with one CLI. There are a lot of other features to be interacted with this feature to work. So hence I have created a configuration task list. I'll be explaining in detail about these configurations in the next section. First, we need to disable the IP source lockdown feature. This is only for getting more resources for the IP flow table. And for the flow tracking, we have to enable the flow tracking feature. And next comes the reflexive PAP creation. That is the new 10.13 CLI is introduced and association of this PAP for the user role. And we need to do a mandatory GPP role ID assignment as we are using the FlexTCAM lookups. And globally, this feature has to be enabled. Only then it will be working. For that purpose, we have to enable globally this reflexive PAP feature. So this is also a new CLI introduced as part of 10.13 release. And last but not least, our main security features has to be enabled. So next comes the configuration task list for the reflexive GBP. So the workflow remains the same for other things. Apart from that, we will try to enable the VXLAN infra first. It can be either static or EVPN. And we will try to create the GBP rules and then the policies and associate that policies to the rules. And we will try to enable this reflexive GBP feature as well globally. So these two configurations are newly added as part of 10.13 release. So let's see in detail about these new configurations for your better understanding. First, as I said, there needs a global CLI knob for these features to be working. So these are independent one. If you are using reflexive PAP, you need to enable only this port access reflexive policy enable CLI. So in case you are using reflexive GBP feature, you have to use the CLI globally. Port access reflexive GBP enable. So these are the mandatory global CLIs to be enabled for these features to work. So once we have enabled the CLI, we have to create a policy for the reflexive feature. So here is the policy context for you to identify what are the existing policy action fields. Like for a policy, we will associate a class. It can be either IP or IPv6. So these are the supported actions currently. The new action is the reflect keyword. That is for the reflect feature. Only when this keyword is enabled, this reflexive policy will come into the picture, and it is by default the permit flow. So once you created a class, you can associate that class to the policy with action as reflect. So similarly, for reflexive GBP creation, I'll be creating either a GBP IP class or GBP IPv6 class, and will be associating that class to the GBP policy with the action set as reflect. So by default, it is permit, and even with this reflect, the workflow is permit, and we have options to drop as well. That is a pre-existing action field for the reflexive for the GBP feature. For the reflexive GBP feature, only reflect is the supported action keyword. So we can associate that action reflect to the GBP IP or GBP IPv6 classes. So far we have seen about the port access policy, reflexive and reflexive GBP configurations. So now this is the DUR configuration for the reflexive PAP feature. So we support the DUR for this reflexive PAP feature, where the entire policy configuration and the rule configuration exists in the ClearPass Policy Manager. So this is a sample where I have created the classes and associated that class to a policy with one of the class having the action as reflect, and created a rule with associating this reflexive PAP policy. So one check to be made here is the GBP rule ID mapping. Through CLI, we will try to configure the rule ID mapping for LURs, but it's mandatory to do the same for DUR as well. Even though the rule configuration exists in the ClearPass Policy Manager, the base rule name. So here the base rule name is Windows. So this base rule name GBP rule ID mapping has to be configured only in the switch. It cannot be possible in the downloadable user rule profile configuration. So next comes the REST configurations. Through REST API, how we can perform the port access policy with reflexive action. So through REST, there are multiple steps to be followed. First, we need to create a action set. So these are the listed action set, and Reflex is one of the action set. So this action set, once it has been configured, it will be next associated to the policy. So here we are creating a policy config entries where for a class, we will associate this action set. So it's like for this class, the action will be reflect. So it's like mapping is we have to create a class and then action set for the class and then associate those two entries in the policy configuration context. So the same applies to the GBP as well. So the series of steps to be followed first is creating a GBP IP class or IPv6 class. And for those classes, you need to create an action set. So this action set should contain a reflect as true in case of reflexive policies. After creating this action set, you will be associating that action set to the class entries in the policy configuration context. So the class is already been created. For that class, we are associating the action set. So that is how we can able to do the risk configurations for the PAP and then the first GBP. So as I said earlier, I'll be explaining in detail about the configuration task list here. So for the client to be onboarded with the reflexive PAP, let's see the configuration task list. So first is IP source lockdown resource extended disabling for increasing the IP flow table size. So next is the flow tracking enablement. Next is the classifier statement creation you have to do. So once that classifier statement is created, you have to associate to the policy with action as reflect. And this policy has to be associated to the rule. So this completes the configuration for that. So next comes the GPP specific like role ID assignment. As we are using the FlexTCam for the PAP, the role ID is mandatory. So we need to create a GPP role ID mapping. Next is globally, you have to enable the reflexive policy feature. Only then this feature will be effective. And next comes the .NX or MAC authentication configuration. As these policies are applied only for secure policies, we will try to enable .NX and MAC authentications in the client connected interfaces. So we have to follow this workflow for this feature to work successfully. So once these configurations are complete, then try to onboard the clients. So you can check the client details in this show port access client show command. So there is similar configuration task list for GBP as well. So first is the VXLAN infra bring up for the VNBT to happen. Next is similarly you have to disable the IP source lockdown to tracking enablement. And we are creating a GBP IP or IPv6 class here and associating that class to the GBP policy with action reflect. So once that is completed, you will do the user role creation and we do the global enablement of Reflexive GBP. And we also do the GBP enablement and then the role ID mapping. So finally, you have to enable the .NX MAC authentication configurations and then onboard the clients. If there is a difference in this configuration task list, they can be either the client will move in the authorization failed state. So that's the reason once these configuration steps are completed, we would recommend to do the .NX and MAC authentication enable on the float and then onboard the client. So we'll come to the demo session here. So I'll be splitting the demo in two parts. One is the reflexive PAP demo. So I'm using the workflow whichever I've created initially for the explanation. Consider a client and then a server. The client is trying to SSH to the server. Only when the client initiated the SSH, the server can respond back. So on top of it, I wanted to verify the network connectivity. So the ping between the server and client has to work, but it is completely non-reflexive, where I do not want it to have a control only when client initiated or server initiated. And apart from that, we do not support ICMP protocol in the reflexive policies. So for that configuration I have created is I have used two classes here. One is for the ICMP and other is for the TCP, specifically SSH, and associated them to the policy, and that policy will be applied to the end client using the rule client here. I'm associating that client to the rule client and then policy and the corresponding VLAN. And the rest of the remaining configuration task lists are present here. So once the client has been authenticated, you need to verify the show port access client's detail. And you can also verify the resource consumption using show resources. And once the flow has been generated from the client and server, you can verify using show IP flows. So let's quickly go to the demo screen now. So the foremost thing I would recommend to check is show feature pack. It should be in valid file based or any of the feature pack modes with state as feature pack installed and valid. It could be either in active mode or honor mode. So once we have this feature pack installed, both the features has to be displayed here with the subscription status either active or honor. So now I have created the topology with the switch, server, and client. First, let me validate the recent version, whether it is the latest 10.13. And I've used a two-member VSF for that. There are clients connected in a different switch and then the server belonging to the different switch. So the client is connected to the standby. This is the client connected port config. It's a colorless purely. I have not configured any other parameters apart from the .NX or macauth. So let's check the client whether it's onboarded. It's not yet. So this is the rule I'll be applying for the client with VLAN access 10 and then policy is the sample reflexive. So let's check the show port access policy sample reflexive config. So I've created two classes, ICMP and then the SSH. ICMP is simple permit, SSH with action as reflect. So now we'll check the IP flows. Its flow table is empty. We have not initiated any traffic from the end client. Show resources, that is also empty. The client has not yet onboarded. So now let us try to onboard the end clients. I'm trying to ping the server connected interfaces. So now the client has onboarded successfully. You can check using detail command. The policy and then the VLAN is applied. With action as reflect for SSH class. Show resources, you could see the resource consumption happen both in the members. So in the client connected, it is only the regular and flex, but in other member, it is only the flex TCAM. But I have not initiated any traffic from the client, so the IP flow is empty. So now let me try to onboard the server interface and try to ping the client from it. So as I said, it is only for TCP UDP traffic IP flow manager. There won't be any flow created for it. And as I have allowed the ICMP from the client to server, even without the client initiating any ICMP, the ICMP can be started from the server and it is happening successfully. So now let me do the actual reflect flow. So I will stop the ping and let me do a SSH session from the server to the client, which is not a valid workflow. So you could see it will fail as we are making sure only the reverse flow will be allowed, but the reverse flow is not matching this criteria. So the SSH will time out. So what I will do is now I will try to start the SSH session from the client to the server here. Yes, the server session establishment has happened because we support a reflect action. So only when the client initiated the SSH, the server could able to respond back. So now we can verify using the show IP flow as well. So the flow has been programmed from the client to server and from the server to client reverse as well. So you could see here it is for the port number 22, that is SSH. And the source port, destination ports, and IPs are exact reverse of them. So this is how this reflexive policy helps in controlling the client initiated session. So only when client initiated the session, the server can respond back. So now I terminated the session. Let's check show IP flows. It's immediately removed. So thereby we are able to achieve that, like only when the client session is active, the flows remains in the switch, but the client is still active. I'm just disconnected the TCP session alone. We'll check show resources. The resource consumption is still active. So the next step is I would try to disable the client port. So here comes the resources will be cleared automatically. So we have now come to the end of the Reflexive pack demo. Let me go back to my other screen. So here comes Reflexive GBP demo. So I am using VNBT deployment here. There are two access VTEPs, VTEP 1 and VTEP 2. VTEP 1 is connected with admin with 10 network VNI, and then with the employee with 101.20. So both of them are VNBT clients. And let's see the scenario here. So the major condition here for me is admin to employee interactions. So the ICMP between the admin to employee has to work, that is non-reflexive, and the TCP between the admin to employee, I wanted to restrict it. So only when admin, like ICMP has to be enabled, only when admin initiates the TCP sessions, it has to be successful. Consider the employee is initiating a TCP session. For example, telnet, it will not be allowed. So when the telnet is initiated by the admin, it will be allowed. So this scenario we'll be seeing in this demo. So for that purpose, I'll be creating the configurations in the access VTEP first. So I have created two classes. One is for the ICMP allow, and then a MAC class for the R to allow. And then for the TCP to be reflected, I have created a sample TCP reflect class where I have mentioned source rule is employee and destination rule is admin. So only when admin initiates the traffic, the response can come from the employee. And I've applied that to a sample GBP reflexive policy and associated that policy to the admin role here. Apart from that are remaining configuration task list configurations. So in case of access VTEP 2, I do not want it to test the reflexive policies feature. So I have made it a pure GBP. So I've created a class for ICMP allow from admin to employee, TCP allow from admin to employee, and for allowing the ARP entries, I have created a GBP MAC class. So I have associated those classes to sample GBP employee policy, and then this policy is being applied to the role employee. So now first the access VTEP, the admin will be authenticated. It will be successfully applied the policy. So you can check the show resources for the resource consumption and then show IP flows for the flow programming. So this is the tabs open for the access VTEP 1, access VTEP 2, and then for the admin and then employee. So first let us validate whether the VNBTs or VXLAN tunnels are up between those VTEPs. So those the VTEPs are operational now. Let me check in the access VTEP 2 as well. So let me go to the VTEPs and check whether it is operational or not. Both the access VTEPs are operational and they're using the same VLAN. We are not one for that purpose. So let's check the interface configuration for the client. It is a pure cloudless port. I have enabled only Autonex and MAC authentication. This is the client connected interfaces. Similarly, even for the other side, it is a colorless port. So now we will try to check the role configuration. So this is the sample reflexive GBP policy applied with the access VLAN as VLAN 101. Similarly, for the other side, it's an employee role. This is the configuration. So let's check the configurations of the policy now. So it will list the policy configurations where there is a IP GBP's class ICMP allow, and then MAC class with ARP allow. And then I wanted to reflect the TCP application. So I've created a sample TCP with action as reflect. So let's check using show run the details here. The association of the classes. And next is the class configurations. So we'll do the same thing in the other access beta as well. So I have created a non-reflexive policy here, permitting the ICMP and ARP from admin to employee, and then permitting the TCP as well. I'm not doing any major restrictions apart from that here, and associating to the GBP policy. So we'll now onboard the end clients. Before that, let's check the IP flows. The flow table is empty, show resources. So these are the initialization resources that will be consumed by the GPP feature. So they are one-time consumption only. Let's check the show port access clients. I'll try to ping the gateway from both the end clients to try to onboard them. I'm just pinging only the gateway here. So both the end clients would have been onboarded now. For detail, you can validate the application of the policies. Similarly for the other access VTUP. So now we'll stop this and try to ping the from employee. I'm trying to ping from the admin now. So since it's a non-reflexive, we do not have any control. This ping has to work successfully. Yes, it is working as it is. So now the exact workflow of the reflexive policy will be trying it. So before that, we will check the details here. Since it is ICMP allow, any ICMP packet from the employee to admin will be allowed. But in case of TCP, it is a reflect. So we'll start a TCP session. I'll be using telnet for the purpose. So the employee to admin, the telnet has to be a reflect only. So let me do the telnet now. So the telnet connection will not make up. As there is no client initiated session. So we'll now terminate this. And there won't be any programming of the flow table as well, as it is not the allowed flow. So now we will do a telnet session from the admin to the employee. So the telnet session is successful. Now we'll be able to log into the employee account. So let's check in the access VTUP 1. So those flows are being programmed correctly. So it's like the source and destination IPs are reversed, and then the port numbers as well. So there is a matching flow entry only, then the response from the server is honored. Even you can check show resources for the flex and programming of the TCAMs. So now let me try to terminate the session. So we'll go to the admin and then exit the session. So you could see the show IP flows, the session flow parameters will be removed, and show resources, it will be present still because the client is still available. It's not been terminated. So let's log off the client as well. Let me shut the client connected interfaces. So if you could see, Azure services came back to the first state. So this is how reflexive policies with respect to GBP feature can able to restrict the flow of traffic from one user to the other user. So with that, we have come to the end of the session. Thank you everyone for watching this video. If you have any further queries, do reach out to us in our AREDS community. Thank you all once again. Bye.